Okay, so this video is going to be about writing functions. So we're given a graph, we're given some criteria, and we need to write the functions from the graph or from the parent function. So the first graph that we're given is this graph here. And we can see that it has a v, so we know that this function, or that this graph, is an absolute value. So the basic generic form of my absolute value function is f of x is equal to the absolute value of x. That's my parent function. And from that, I can translate this graph anywhere I want using some basic protocols. So the first thing that I'm asked to do is I'm asked to translate 4 units to the right. So, and if I remember correctly, to translate to the right, I need to know where in my equation this goes. So my translated function is f of x is equal to a times the absolute value of bx minus h plus k. And a, b, and h are my generic terms that tell me what's happening. A is my vertical compression or stretch, and this will actually reflect me over my x-axis. B is my horizontal stretch and compression, and this reflects me over my y-axis. H is my horizontal shift, so my left or right, and K is my vertical shift, so that's my up and down. So this tells me that I want to translate 4 units to the right, so this is going to shift my H value. So f of x is equal to x, and 4 units to the right, and if I remember correctly, H is my hypocrite, so if I want to go right, I'm actually going to write this as a negative 4. The next thing that I'm asked to do is I am asked to reflect over the x-axis and translate up 5 units. So to reflect over my x-axis, that's going to be my a term. A negative a will reflect me over my x-axis. To translate up 5 units, that's my k term. That's my vertical translation. So when I rewrite this, I need to do f of x is equal to a negative absolute value of x plus 5. The negative is what is reflecting me over the x-axis, and the plus 5 is my translating up 5 units. This is my rational function. My rational function is f of x is equal to 1 over x. This is the parent function of this graph. When I write this in generic terms to figure out what I'm going to translate, my generic form of this is f of x is equal to a over bx minus h plus k. And everything has the same thing as before. A is going to take care of my vertical stretch or compression and reflection over the x-axis. B is taking care of my horizontal stretch and compression and reflection over the y-axis. H is my horizontal change, and K is my vertical change. So what I'm being asked to write for this one is I'm being asked to write a function that translates down 7 units and 3 units to the left. And I have to figure out what goes where. So down 7 units, that's my K. 3 units to my left, that's my H. So I don't have an A or a B translation for this parent graph, so I'm not even going to write them. So my f of x is equal to 1 over x. 3 units to my left. Remember, it's opposite because it's a hypocrite. It tells me the opposite way. So a left would normally be a negative, but in this case, I'm going to put a plus 3, 7 units down, so minus 7. So the next problem wants a horizontal stretch by a factor of 3 and a translation to the right 2 units. So a horizontal stretch is going to be by a factor of 3. It's a horizontal stretch by a factor of 3, so that's going to be my B. And to the right 2 units, that's going to be my H again. So horizontal stretch by a factor of 3 and to the right 2 units. So f of x is equal to 1 over 3x, and to the right, that's my horizontal stretch, is the 3, and to the right 2 units means that I'm going to go, again, it's not going to be negative, or it's not going to be positive, it's a hypocrite, so it's going to be minus 2 is going to take me to the right 2 units. Okay, so the last example like this I'm going to do with the graph is going to be my step function. That's also known as my greatest integer function. I've heard them called both ways. Either one works for me. The parent graph for this is f of x is equal to, and this is a double bracket, or it can be just like a really, really bolded bracket, but a double bracket x means that I have a step function. So the generic parent, or the generic transformation of this parent graph is f of x is equal to a, the double bracket, bx minus h, double bracket, plus k. And everything is the same thing. A is going to be your vertical compression or stretch and your reflection over your x-axis. B is your horizontal stretch and compression, your reflection over your y-axis. H is your horizontal shift, so left and right. And K is your vertical shift, so that's your up and down. So if I am going to translate up 1 unit and vertically stretch by a factor of 4, I have to figure out what parts that manipulates. So up 1 unit, that's going to be my K, and a vertical stretch by a factor of 4. So a vertical stretch by a factor of 4, that's going to be my A. So when I write this, I'm going to say f of x is equal to 4 double bracket x, close my double bracket, plus 1. So this one says that I'm going to vertically compress by a factor of 1/3 and translate 6 units to the left. So vertical compression by a factor of 1/3, that's still going to be my A, and translating 6 units to my left, that's going to be my H. So when I write this, I'm going to have f of x is equal to 1/3 the double brackets x, because it's a horizontal shift inside my double brackets, it's my hypocrite, so I know I want to go to my left, but I'm going to put, instead of a negative, a positive 6 and close my double brackets. So anytime I'm doing any translation or transformation from a graph, I'm doing the same thing. I'm finding my parent graph, and every parent graph is going to have your A, B, H, and K in the same positions. The only thing that's going to change is the actual function of the graph itself, of the parent function itself. So, but all the components of your A, B, H, and K are still going to be there the exact same way. Okay, so this is the last one we're going to do, but it's fairly simple. So I have an equation that's already been translated. I have 2 times x minus 5 cubed plus 3, and this has already been translated. It has a vertical stretch by a factor of 2. It's moved 5 units to the right and 3 units up. But After this happens, then it's reflected across the y-axis, then translated 6 more units to the right, and then 2 units down from this location. So what is the result after all of this has happened to this? So I need to add this part of my transformation into my existing equation. And that's kind of what I need to do. That's kind of where we're at. So basically, where does the reflected over the y-axis goes? Well, that's going to go in front of my x. Where does the translated 6 units to the right, what does that affect? Well, that's going to affect my -5. And the 2 units down, what does that affect? That affects my 3. So I'm just going to affect the parts that's affected and not change the parts that's not. So f of x is going to stay the same. So I'm still going to have f of x is equal to 2. So reflected over the y-axis means that I need to put a negative there. The x is going to change. So if I have a -5 and I'm going 6 more units to the right, again, because it's my hypocrite, it's not going to be a +6, it's going to be a -6. So -5 minus 6 is going to give me a -11. And then I still have to have my closed parentheses. I still have to have my cubed. I have a +3, but then I'm going down 2 units. 2 units down means I say -2. So 3 minus 2 is a +1. So this is my result of the translation after I translated it more times, after I had more things happen to it. Okay? So this is my writing transformations or translations based off of a graph, which gave me my parent functions and then parameters for that parent function, and then off of a translation, and then more translations or transformations to that original translation.